Next, we're going to add the stretch function to our spine. Um, to do that, we're going to use the combination of nodes to create that result. So far, everything we've done has been essentially in the viewport using basic parenting um, constraints and IK handles to create, again, dependencies and uh, influences to make one object control another, so on and so forth. Another way we can do that is by manipulating and connecting nodes and using uh, essentially math to drive different values and convert different values to make them usable to drive other bits of information. So for our example here, what we've got is the spine, which is being driven by this spline curve that currently, as we stretch it, we are stretching the curve and making it longer, but the joints are not coming along for the ride. So if we can figure out the value that this curve is changing by, and essentially as a percentage of what it originally was. So if it's being stretched by 5% or 10% or 20%, then we can take that value, the same percentage, and scale the bones or the joints by the same amount, essentially equalizing the distance that the curve is stretching. And if we can get that done mathematically, then we'll essentially have our stretch problem solved. So to do that, we're going to use the node editor. So I'm going to go to Windows, Node Editor. If it's already got things in there, just click the clear button here, clear graph, to start fresh. And we're going to need, actually going to expose my outliner here so I can drag things over. And yeah, we're going to need our spine. So I'm going to select all the spine joints and middle click and drag those into my node graph. And I'm also going to need the curve itself, and specifically I'm going to need the shape node, but I'll just drag the curve itself in and see what I get. You can see I get 3 nodes, but the shape is the only one that I'm going to be using, so I'm going to put the other 2 off to the side here for now. And I'm going to need to create a node to work with, because the shape node actually has all the information I need, but it doesn't output it by default. It pretty much has the absolute value of where each of the construction points of that curve exist in space, but it doesn't actually produce the length. Now the information is there, we just got to expose it. And in order to do it, we're going to need to create a specific node. So to create a new node, if you know what the node is, which I do, and I'll tell you specifically what to search for. If you hit the tab key, you're going to get a type in box, and we're going to be looking for the curve info node. So I'm just going to type that in, select it, and hit enter. And that's what the curve info node looks like. And I'm going to select both the curve info node, and the shape node, and I'm going to, with them both selected, I'm going to hit the 2 and 3, and actually I'm going to need the 4 key. So you can see if I cycle between 1, 2, 3, and 4, it's 4 different levels of essentially exposure for each of these nodes, and obviously the shape node has a lot of hidden information, and we're going to tap into that to feed some curve information into our curve info. So the reason we need 4 is because it's the one that opens up the curve input value, which is what we need to plug our curve shape into. So the value we're looking for on the curve shape side of things is under world space 0. World space 0. So grab that and drag it into the input curve. Once you've got that, you can select the curve shape and hit 1. That's the only bit of information we actually need from that, so you can simplify it. And then the curve info, go ahead and rename it. I'm going to call mine curve underscore length. well, actually I'm going to say spline underscore length. And if I double click on that, you can see now I've got an arc length value, and without a curve shape node to feed information into this info node, that would be blank. But right now it says 51.928, so that's in centimeters, so the current length of the curve is 51 centimeters. I'm just going to tear that tab off so I can see it as it changes. So when I select the controller and stretch it out, you can see now that value is in real time updating, and obviously changing its length. So now it's 94 centimeters long. So if I can get that information into a little bit and use a little bit of simple math, I should be able to figure out the percentage length by dividing the result length by its original length. And to do that, I'm going to need a multiply divide node. So I'm going to come back over to the node editor, hit the tab key, type in multiply divide, choose it, hit enter, and I'm going to name it right away. I'm going to call it, so the naming conventions I would recommend are essentially call it what it's doing, and then at the end add the operation that you're using to solve that equation. So this one is going to be calculating the percentage length of the curve. So I'm going to say spline length underscore PCT for percent underscore div for division. Now the reason we're using division is, again, it's pretty much the equation for percentage. If you take a value and divide it by another value, you'll find the percentage of those two numbers. So in this case, I'm going to take the arc length, I'm going to plug it into input 1x of the multiply divide node. So we've got that connection there. Close that, and I'm going to double click on that, and so you can see what it's doing is it's feeding the arc length value. I just tear that off, so it's floating, and adjust it. You can see that's updating along with the curve length. So what we want to do to find the percentage of this value is to divide it. So right now it's set to multiply, so make sure you switch it to divide, otherwise this won't work. Divide it by its resting length, which is the current value. So I'm just going to copy and paste 51.928. So if I change that, whatever the value is of 80 divided by 51.928, again, that will solve the percentage length of that curve. So if we can plug that value, which is right now available as an output, into the spine joints themselves, they should be able to update their length accordingly. The only one we don't need to plug in is the last one, because that one doesn't have a child. You only have to worry about spine joints that actually have another bone after it. So you don't need to plug a value into spine 3. So I'm going to click on output X. I'm just going to start with the hip, scale X, because X represents the length of the joint, and it's going to keep daisy chaining that. Now you may have to open up with the 2 key once you got one plugged in for the multiply divide node to expose the output, and again you're looking for output X, and then you should be able to just daisy chain each of them in. So scale X, and just keep doing that all the way up to spine 2. Scale X, output X, driving scale X, and again you skip the end joint, that one doesn't need it. So now with that done, if I just minimize this and have a look here. Now if I move my spine controller, it's feeding the appropriate, again, percentage value into the scale of the spine joint, and it's able to resolve and match the amount that we're stretching the spine curve, or the spline curve, effectively taking care of that problem where we're stretching the object further than it's able to, the spine is able to reach. Now, if you're going to do if your character is more realistic and you're not going to get into the cartoony realm, and you're not going to go to the extreme squash and stretch poses, then you might not actually need to add a squash value, but it's still a relatively easy thing to add. Again, it's some other nodes and some more math to figure out the proportionate scale in Y and Z to maintain the volume as the X value is stretching out. So I'm gonna, because it's somewhat optional, I'm gonna put that in a separate video, and we'll pick that up in the next one.